Welcome to Materialchef, preparing the most influential materials for your delectation. Whether it's scraping the cake mix from the bowl or washing up after a late-night dinner party, rubber bends, squeezes and stretches its way into our everyday lives. Rubber can be used to make flexible pancake flippers, elastic bands, rubber sink plugs, washing up gloves, and not to mention tractor tyre inner tubes. It is important to source products locally, so we have tracked down a tropical rubber tree here in Cambridge at the Botanic Garden.
So I'm standing under Hevea Brasiliensis, the tree that's used to commercially produce rubber. It was initially collected by Henry Wickham in 1875 in South America, Brazil, where the seeds were returned to the Royal Botanic Gardens Kew and then distributed around Southeast Asia to be grown in plantation, as it's not possible to do this in South America. The latex from which the rubber is extracted is produced by the tree just underneath the bark, and you have to tap the stem by cutting it with a knife to get at that latex. The latex in itself constitutes about 55 to 70% water and about 30 to 40% rubber. So the vessels fall just below the surface, and if we cut into the tree as so, the aim is to keep the tree alive for as long as possible so that you can get as much rubber out as you want. Just take the tapped area out. We should see the latex start to build up on the edges and it will run down the channel. And after a night of tapping the tree, here's your latex.
People in Mesoamerica are said to have dipped their feet into liquid latex that was dried in layers to form rudimentary shoes. We need some new rubber kitchen gloves, so let's see if this works. Leave 10 minutes between layers to allow time for them to dry. When it is dried, you can peel it off like a glove. However, this rubber tears easily. Our yellow rubber gloves are more durable, as they're made from vulcanized rubber. Let's try vulcanizing some rubber to see how it helps. First, add a generous soupçon of sulfur and stir vigorously. Spoon the mixture into a mould and then allow this to dry naturally. Here is one we dried earlier. It is very flexible and sticky to the touch. Place the dried rubber onto a metal plate and add a probe to monitor the temperature. Screw down firmly so that the rubber is under compression. Place onto an even flame and heat to 130 to 140 degrees centigrade. That's gas mark 1 for 1 to 2 hours. Remove the plates and allow to cool before carefully unscrewing them and removing the vulcanized rubber. But what is the difference between the dried and vulcanized rubber? Natural rubber is made out of individual monomers which join to form longer polymer chains. When the material is stretched, the bunched up polymer chains lengthen. Brownian motion causes the monomers to bash into each other, shortening the chain. This is what makes rubber stretchy. In natural rubber, the chains are entangled. When the material is stretched, it is easy for them to separate, making the material sticky, and it can be torn easily. The vulcanized rubber is no longer sticky to the touch or susceptible to tearing. When sulfur and heat are added, the polymer chains become cross-linked with sulfur bonds. When these chains are stretched, they are more firmly attached to each other and so do not separate as easily, and again return to the coiled position when they are released. Rubber is a natural product that can be easily harvested, and with a little vulcanization it can be made strong and durable, yet remains highly flexible. Its unique combination of attributes mean that it will continue to be widely used and heavily relied on for years to come. Tune in next week to satisfy your insatiable appetite for knowledge and dig into what makes the materials we use just so special. With the Materialchef, brought to you by the Naked Scientists.